Okay, try to please wrap it up in the next couple seconds. Rate of change, you're really just finding the slope between 2 points. So if I give you a table of values, are there a lot of points written out there? What are the 2 points that I need to find the slope between for the first question? What are the... Yeah, 0, 0, and what? 250. So that's really just the slope between those 2 points. Oh, thank you. Actually, thank you. So what do you need there? 50 minus... So what's the slope going to be? 50 minus 0 over. So what's the average? It says what's the average velocity? 25 feet per second, right? What's the car's average velocity over the second 2 seconds? What are the 2 points there that we need, Lindsay? What are the 2 points we're going to do the slope between on this one?
476.
Yep.
250.
And 250. So what's that going to be? 76 minus what? Mm-hmm.
Over 4 minus 2.
4 minus 2, so that's what? 26 over,
2.
which is? 13 feet per second. How fast is the car going at 2 seconds? Now that's not an average rate of change, that would be the slope of the tangent line. So this function, if you plotted these points, could you connect them with a curve and get some sort of function? Maybe some, you don't really know, right? Does everybody understand what a tangent is? What does tangent mean? Anybody take Latin? Tangent? Touching, so it touches once, So how would you go about using this table of values to find out the instantaneous rate of change at 2? At 2, you have to estimate it because we don't have a function yet and we don't have a way to find that instantaneous one. But if I just gave you this and I said, what's the instantaneous change there? What would you draw? You would draw the tangent line, right? And you would find the slope of that tangent line. Given the table of values, there's a couple ways we can estimate it. Anybody want to guess how to estimate it? So we don't have a smooth curve. What do we have? We have specific points, right? We have these points. I'm just dramatizing those points there. What math would we do to find this slope, to estimate this slope, given those points? Anybody want to guess?
2 points.
We need 2 points. Which 2 points do you want to do that would estimate the slope at x equals 2? It would estimate it. What 2 points would you use?
Before.
What'd you say?
Before and after.
Yeah, so you could do 1.5 comma 39.4, and what's the other point you could use?
2.5.
2.5 and? So that's one way. Pick the closest points around it. Or there's another way. Some books like to do it a little differently. They start at the point, and then what do? They go forward 1 unit. In this case, when I say 1 unit, I mean the next point. What's the next point in this case?
2.5.
Comma 59.4. Either one of those is acceptable for me right now. Either one. Either take the points immediately around it, or pick the point itself and go 1 to the future. That's the best way to estimate it.
You can't go 1 back.
Well, the thing, you could sometimes, and sometimes you see this. There's actually a third way. There's a third way. People do this. They take the 2 points before, they take the point before, they take 1.5 comma 39.4, right? And what? What's the other one? 2 comma 50, and then what do they add to it? They average it, and 2.5 comma 59.4 like this, and then they divide it by
2.
So there's 3 methods here. There's really 3 methods. It totally is up to the function which one's going to be the most accurate. Any one of those is okay for me right now. You could average the front and the back. The most common you'll see in textbooks is honestly this one. You'll see this one. Starting at where you are, go forward 1. This is the most common. So if you want to default to one, I kind of like this one the best because it's the most common. The third one sometimes works best, but why would you not choose the third one generally?
It takes longer.
Takes longer. Yes, it takes longer. Now on this kind of math, what would I usually allow you to use?
Calculus.
Yeah, but it's not impossible. The decimals actually aren't that bad. They aren't that bad. So you could graph these points. Now you could graph these points and see what's going on. So what did we do? We connected, like on the first one here, from the first 2 seconds, that's from here all the way to that point. So that's this slope of that line. That's from 0 to 2. And then we did from what? 2 to 4 right there. That's the slope there. And why does that picture match the numbers we got? We got what, 20, 25, right, as the slope? And then what did we get for the next one? Like 13? Do those numbers match what we see?
Yeah.
Why?
Because the slope of the higher one.
The
is
red,
higher,
yeah.
You can tell that it's less.
Less than. It should be less. Now the scale is different here. You see how the scale is tens on that one and singles on the other? So that's why it's not like super straight up. It's not super helpful because a slope of 25 would like look like this, and then you're like, it doesn't really help us that much. So in this case, is the average speed going up or down? Is the average speed going up or down? Well, it goes from 25 to what?
Yeah.
So the average speed is going down. So this thing, you could say this car or whatever is doing what? It is slowing down. You could say this is slowing down. You could say it's slowing down. Pretty cool. Okay. So what we're going to do is we're going to generalize this. And this is math we just were practicing. Let's say we picked an x value of a right there. Here's that point right there. And we go this distance away. We go h away. So what's the x value here? A plus h is the x value here. We don't have the function, so we'll say f of a plus h. What's this coordinate right here? A comma what? F of a. So how many points do we have?
2.
We have 2 points. We have 2 points. Could we find the slope between 2 points? Can you tell me, Noah, what's the slope between these 2 points? What's the y value of the second point?
F of a plus h
Yep.
minus f of a
Yep.
over a plus h minus a.
A plus h what?
Minus a.
Can you simplify that a little bit?
Uh,
It's f of a plus h minus f of a all over what?
h.
H. This right here is super common. You're going to see this many, 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 many times in
And
your
that's
life.
the answer?
That right there would be the answer right now, because did I give you a specific function? No. Did I give you an a value? No. And I haven't told you what to do with it yet, but that right there is a quotient. It's a difference quotient. It is super, super important. So here's the thing. If I'm estimating right there, that would be the average rate of change between x equals a and x equals a plus h, the slope of that blue line. That would represent the average rate of change between these two. What did I say you would do if you wanted the instantaneous rate of change right here? Like, if you wanted to know how fast you were going on this roller coaster right here, you'd want to draw the what line? What's that called? You want to find the instantaneous by drawing this is the secant line, but what's that called? Tangent line, right? So here's the thing. Let's say I were to take this point right here and march it down towards that x equals a. So I'm going to march it here and here. Could I draw new secant lines?
Yeah.
So I could draw new secant lines. They're going to ones that look like this, like that, like this, like this. Each of those is the average rate of change from here to here, from here to here, from here to here. What do these average rates of change get infinitely close to? The actual instantaneous rate of change right here. As you get closer, when we have that table of values up here, why was it an estimate? So when I asked you, find the average rate of change at, so not the average, the instantaneous rate of change at x equals 2, you chose, we could either do the average of these two or just these two. Why is it an estimate? Well, there's a gap here of 2 to 2.5, right? How would you get a more accurate guess for the instantaneous rate of change? You would want these 2 points to be closer together. You want this gap to be smaller, right? You want the gap to be smaller. Which number on this picture right here?
You do want the gap.
You want the gap to be smaller. The smaller the gap, the better the estimate for the instantaneous rate of change. On here, what number represents the gap? H represents the gap. A is fixed. H represents the gap. So what kind of limit are we looking for? If this is the slope, we want to look at it as what goes to 0. Yes, this right here, the limit as h goes to 0 of f of a plus h minus f of a all over h, this is the instantaneous rate of change at x equals a. This is the instantaneous rate of change at x equals a. So, what kind of function can f be? Anything you want. What value can a be? Anything in the domain. You run this limit. Are all limits easy to do? No, but if you can run this limit, can you find the instantaneous rate of change? What types of questions could we now answer? I could give you a function that says a car is traveling at this function for velocity. What could you find? Or this function for, this is the distance. This is where the car is at a certain time. You could find how fast is it going at every point. But you have to run a limit each time. You have to run a limit each time. So this part goes right there. So let's do a concrete one right here. Concrete one. So this is what we just figured out right here. This is what we just figured out. 0. So when you're doing the algebra here, usually what's your target the entire time? Cancel out the h. You're going to have so much practice canceling out the h. So much practice. So much practice. So we're going to do one of these together, and then you're going to be set off to do one by yourself. It says, suppose a person is walking along a straight path, and his distance from home is given by f of t equals 2 to the t. So this is his distance from home, 2 to the t. I'll write it bigger. Find his average velocity over 2 to 3. This is part of the domain. So are those x values or y values right there? Those are x values. So if we want to find the average velocity, you want to find the slope between 2 points. Can someone raise their hand and tell me what the first point is? 2 comma Noah. 4. And Natalie, what's the second point? 3 comma 8. How'd you get 8, Natalie? 2 cubed is 8. Can you tell me how to find the slope between those 2 points?
8 minus 4.
Over?
3 minus 2.
Yes.
Which is 4.
Which is 4. So what's that speed going to be?
4 feet per second.
Yes. 4 feet per second right there. So that's the average rate of change from 2 to 3. Estimate the instantaneous velocity at t equals 3. And this is where you need to, at the beginning, you're going to have to write the difference quotient just immediately so you do it properly. And it was, do you remember, the limit is what goes to 0? Limit says h goes to 0. Oh, I can almost write a 0. Almost. It's like the easiest thing theoretically. F of a plus h minus f of a all over what? H. You must memorize this cold. You write that down and now plug it in. What's our a value in this case?
3.
A value is 3. So we have the limit as h goes to 0 of f of 3 plus h minus f of all over h. Now what is our f of t is what? 2 to the t. So where do we plug that 3 plus h into? Where do we plug it into?
Or the t.
Where the t is, exactly. So it's going to be 2 to the what? 3 plus h minus what? 2 to the third all over what?
Or h.
Over h. Pause here and see if you understand what we... If I asked you this limit and you can't do it algebraically, what would you use? So you love to do it algebraically. Why is algebraically really nice? Usually, and it gives you a definitive answer, right? Or if algebraically fails you, what can you use? You could use a calculator to make a what? Table. You can make it. Do that right now for me. Right? Take your calculator out and make a table. You decide how to make it. What numbers did you choose? You got to be around 0. So what's a little bit to the left of 0? Yeah, so you could do negative 0.999. You could do negative 0.99, negative 1. What's a little bit to the right? 0, 0, 0, 1, 0, 1, and 1. You could fill in that chart right there. You could fill in that table. Do you know how to do that?
Yeah.
How did you do it, Noah?
Just enter the 2 to the 3.
Yeah. You have to make sure you do this carefully, right? It'll look like this on your... I think it'll look something like this on your calculator. Something similar, right?
You have to use
Minus.
brackets,
Yeah.
right?
Mm-hmm.
We'll be messed up if you don't use those brackets.
Like this, right? Did you do that as your y1?
Yeah, well, I just didn't have the brackets.
Ah, if you don't have the brackets, what happens?
I don't-
It changes everything, right? It changes it into 2 to that thing minus negative 8 over x. Totally different. Did you find values for those? Anybody find them? What did you get, Fitch? Come on, what would you want to do? We talked about this.
Get even closer.
Get even closer, right. So if we're looking at 0 here, how close could we get?
Just put a bunch of 9s.
Yeah, so let's do negative point. How many 9s do you want to do?
Let's do 5.
And then what would this be? 1. This would be not 1. It would be what?
4 zeros.
Oh, wait a minute. Look at, can I just point something out here? We made an interesting mistake here. These are the right numbers, but what's the difference between this? What's the difference between these two numbers? 0.001, right? What's the difference here?
Almost 1.
Almost 1. So is this symmetric?
That's what I was trying to say.
You're absolutely right. You're absolutely right. You're absolutely right here. So these numbers are correct, but are they helpful?
No.
Not so much. Arvin, you're totally correct. You're totally correct. So those numbers are correct. I just totally filled that in wrong. But were those numbers correct?
Yeah.
Did we now that we realize they're really far away, did we expect them to be that far away? Yeah. What should we put on the other side? Negative 0.001, right?
Okay.
Negative 0.1 and
Crazy.
negative. Yeah, that's why it was so far away, right? Can someone tell me what happens when you plug in this number right here? Negative 0.001.
5.543.
Oh, 5 point what?
5.433.
33? So we have 5.5433 on the left of it, and what do we have right here? 5.5471. Are those pretty close together? So if you wanted to estimate them, what could you do? You could average it. And would that be a pretty good estimate? Now, if you wanted it even more accurate, could you get even closer? You can't plug in 0, but can you get as close as you want? Yes. So that's how you can estimate it, because here's the thing. We wrote the limit. Yay! Do we have any idea right now how to cancel out that h? Be really careful with the algebra. Here's one thing you might try. What's it look like in both of those things in the numerator? What's it look like is in both? What? 2 to the third, right? Kind of looks like it. So this would be what? 2 to the third times 2 to the h minus 2 to the third over h?
Yeah.
What can we pull out of the top?
It just ends up being 2 to the third. Over
Yeah, limit as h goes to 0, 2 to the third times what? 2 to the h minus what? 1 over h, right? And you're like, yay, that doesn't help me. Because can you cancel h out of anything? So if you get stuck and you have a calculator in your hand, what should you immediately do? Make a table. Make a table, plug in something really close. Because h is going to what? So plug in something really close to 0. Are there going to be ones that you get to do? Are there ones you get to do with algebra?
Yeah.
Absolutely. And what's coming up is that you will soon know how to do this with algebra. And we like algebra because it gives us a definitive answer. It gives us a definitive answer because is this a nice decimal right here?
Yeah.
It's not really. It's not bad, right? But is it a number like 3.5 or 2 or 6 or no? It's not clean. It seems like you want to know, like, when you get a clean answer, it means there's probably a clean path to it. So when you get an answer that's not quite nice, it kind of it's a little bit more involved. It's not that bad. It's not that bad. We need to do a little bit more with derivatives first. We need to do a little bit more with derivatives. So let me clip one.